Hey guys, I got 3 different NuTone Pro Lines here, and I'm hoping to answer some questions, my own questions rather. I picked this one up today. It's kind of unusual. It's a 3-blade 56-inch, but it's got the larger lower canopy. I've never seen that on a 3-blade before, and I always assumed that this larger lower canopy was only on the 48-inch, which none of these here have, but I have some that have that. And I also assume that the larger lower canopy was on the later ones. I don't know what caused me to make that assumption, but this appears to be from '83. This is from '84, and this is from '86, and this one's got the larger canopy. And so that's a little bit confusing. So I guess the question is did the larger lower canopy come first, and which ones were they on? Are there any other differences over the years with the Pro Lines? I'm going to do a video and hang and test this one in a minute. Somewhere around here I have one of the brown canopies for one of these. I bought it. I brought it to Menards to match paint. I don't know what I did with it. Yeah, so I guess that's all I really wanted to talk about there. I'm hoping that somebody who knows these more than I can shed some light on that. As I get a chance to, I'm going to get the data on all of them and see if we can figure out if there's a pattern with these canopies. But like I said, it's really weird to me to see a 3-blader with the bigger canopy. In all my years, I've never seen that, at least of the NuTone version. I've seen other versions with the bigger lower canopy. Yeah, so has anybody else seen any, what other safers have others seen with this canopy? Not this one, whether it's plastic or metal. What safers have been seen with this canopy? That would be some information I'd like to have. Okay, well, I'm going to start getting this one together to test it. Hey guys, this video will serve multiple purposes. First of all, this is a NuTone Pro Line. I believe the model is PFC-56. I'm not looking at the tag on the top. It does have a NuTone tag on the top. And this is slightly different than my other Pro Lines. First of all, it's not the stock lower canopy and upper canopy. It didn't come with the upper canopy. If it did, I'd probably use both stock canopies on it. Since it didn't, and since the downrod it came with was very long, I needed to change the downrod anyhow. I'm using the canopies and downrod from a later, safer, stamped fan, very similar to this. One of those over there, as a matter of fact. And using that in place of the original lower canopy, which is this one here. And I've seen NuTone Pro Lines with this bigger, more traditional lower canopy before, but I've never seen a 3-blade. Did I say braid? A 3-blade Pro Line with this larger lower canopy before. I've only seen it on the 4-blades. And for whatever reason, I thought that the larger lower canopy came later. However, this is an '83, and all mine that have the smaller lower canopy, the brown ones down there, are '84 and '86. So that may mean that the larger canopy came first, or there was some other variation. I don't know. I've got to look at some other ones and get some dates. If anyone else has seen a Pro Line with the larger lower canopy, let me know. And if you know anything else about it, I'd also love to know if anybody else has seen a safer that's not NuTone with the larger lower canopy. All the Airmaster ones that I've seen have the smaller canopy like that. The bottom of the motor looks slightly different too from my other NuTones. It looks like the circle is smaller. These holes for the bolts that hold it together are more noticeable. So I don't know if that's my imagination or what. I'm waiting on Tice, the safer expert, to weigh in. He will surely set me straight. But in any case, testing it here with the non-stock canopies and down rods. Bearings were a little noisy. I didn't test it before, but I spun it by hand. There was a little bearing noise, so I added a little WD-40. It's rated at 0.75 amps. I don't remember what the other ones drew, the brown ones. So that'll be another thing to look at. Now, the second thing I'm going to do, I had some questions on VCF from one of the guys asking about controls. And they asked what I thought was a very obvious question, but I realized it might not be obvious to everyone. And they said if you have a fan that is meant to be used with wall control, like an industrial fan or anything that doesn't have a pull chain, and I'm assuming excluding stuff like IntelliTouch fans that have to use a specific wall control that talks to the fan. But just like a regular fan like this, what happens if you use it without the control? They were wondering what speed you get if you just plug it in without the control. And the answer to that question is that you get high. High is on any control that is like a solid-state control or a capacitor-based control or a transformer control. High is just a bypass. It's just going straight through. It's like an on-off switch, just on. Just current going right through. The fan's getting all the current, all 120 volts. So let's demonstrate that first. Here's the plug here. Hold on, I gotta set this down because I don't have enough hands. Give me just a second to do that. Okay. I'm gonna plug the fan in directly with no control. So it's going to take a little time to spin up to high, looks like, but that's high speed. You see it's plugged in there directly. No control in the way. And we're drawing 0.67 amps, which is pretty close to the rated 0.75. I don't remember where that is in relation to the brown ones. I'm not sure if that's less. It's possible the capacitor in this has drifted a little bit, or I don't know. I'd have to A, go back and look at my videos of the brown ones, and B, test the capacitor. Okay, so hopefully that's made that clear. Now let's wire our speed control in. Just gonna unplug that. I'm gonna set the camera phone down again. And I'm gonna start with the 4-speed capacitor-based control. So again, this may be obvious to some, but not to everybody. With the 4-speed capacitor-based control, speeds low, and medium high are running the current that goes to the fan through a capacitor before it gets to the fan. And the capacitor is, in a way, limiting the current that goes to the fan. So, again, high is a direct short, so it's getting all 120 volts. On medium high, it's sending it through two capacitors, a 5 and a 10 microfarad that add up to 15. So when you have it set to medium high, the fan is getting current filtered through 15 microfarads of capacitance, which changes the phase enough to slow the fan down. It doesn't actually drop the voltage to the fan, but it changes the... And I might be explaining this wrong, but this is the best that I can do. Instead of 60 cycles, it's dropping it to a different cycles so that it is going slower. And then when you have it set to medium-low, it's going through a 10 microfarad capacitor, which is dropping it further. You have it set to the very lowest speed, it's going through a 5 microfarad capacitor, which is decreasing the phase even further. And so each subsequent speed is limiting the current to the fan in some way, so that it is in fact going slower. So let's try it with that control. And that's down here. Here's the 4-speed capacitor-based control. So we're going to turn it all the way to the lowest speed, which is the 5 microfarad capacitor. So what we have here is just the equivalent of if you wired a 5 microfarad capacitor in series with the fan. And let's bring that over here. Everything got moved around a little bit. Drawing 0.26. Now I'm going to turn it to medium-low, whereupon it has a 10 microfarad capacitor in series with it. and it is drawing 0.55 amps. Again, it should be obvious, but it may not be to everybody, that essentially the faster a fan is going, the more current it is going to draw. Of course, that depends, you know, on the efficiency of the motor. That's not to say that there aren't some fans that draw more current than others, but go slower. But with the same fan, for the most part, in most cases, more current draw means faster speed, and that's why we look at the amp meter in comparison. Let's go to medium-high. Medium-high. Oops, where are we at now? Okay. Well, this is not a great example for my video because medium-high is actually hitting a resonant frequency that's actually causing it to draw more current than it should. So, we'll ignore medium-high for now, and I apologize for the confusion. This is high speed. I talked about resonant frequencies in other videos, but it disrupts the simplicity of what I'm trying to teach here. Basically, sometimes if you use a control that uses, doesn't matter which type of control, but, because remember what the controls are doing is they're changing the frequency of the current going to the fan, and if you just happen to hit a frequency that resonates in the motor, it will actually cause it to draw more current and go faster rather than less current and go slower, and that's bad for the control and the fan. And so you just have to watch out that you never use a control that causes a fan to go faster on any speed other than high. So we're under the fan here. Seems like it goes a little slower than my other Pro Lines. It could be a different version, or it could be a capacitor issue. I don't remember what current draw the other ones were. If they were more than 0.6 something, then that might explain it. It's not wowing me on the airflow either, which makes me think that it is going a little bit slow. It's definitely moving some air that I can feel over here, but no, actually, it just took a minute. It's actually moving quite a bit of air over here. So, let's stop it and let it spin down. I'm going to set the camera down and switch controls. Now, transformer-based control is a little bit simpler. Inside a transformer-based control is essentially a coil of wire, and that is actually reducing the voltage to the fan. If you think about it, if you've got a cord for a radio or a keyboard or even a cell phone charger or something like that, it plugs into the wall, and then there's a little transformer, and then it connects to something that would otherwise use batteries. That's what that transformer is doing, is dropping the voltage to whatever voltage your electronics want to see. Usually it's also converting AC to DC, but that's not the transformer that's doing that. That's something else in the power supply. We used to call them wall warts. And so essentially the transformer is just a coil of wire. And so that's what's happening here inside the transformer-based control that I test. So theoretically, what it's doing is on high, it's giving it a full 120 volts. On, you know, speed 2, it's got 5 speeds. The medium-high, it's giving it less than 120. On speed 3, it's giving it less still, 4 less still, all the way down to 5. So let's start on 5. Again, this is drawing 0.25 amps. Okay, speed 4, 0.32. Speed 3, 0.39. Speed, what are we at? 2.45. And then that takes us to speed 1, which should be the same with every control, because if you may recall, speed 1 is a direct short. So 0.66. Set the phone down again and switch controls for the final time. Takes a little time to get up to speed. So the last control that we generally test with is a solid state variable speed control. And basically a solid state speed control is very similar to a dimmer switch. What a dimmer switch does is, well, kind of like a capacitor, it changes the waveform, but in the case of a dimmer switch or a solid state control, it actually chops up the waveform. So instead of a nice smooth sine wave, like you're theoretically getting from the power company, you have more of a, I think it's more of a sawtooth wave. People have often tried to describe a dimmer switch as essentially turning the light off and on so many times that you can't see that it's going off and on, but that it looks dimmer. That's one way to understand it. Now the difference between a dimmer switch, and I'm going off on a tangent here, a dimmer switch and a motor speed control at solid state, is that a motor control has more filtering. Because oftentimes a dimmer switch puts out DC. We'll say on accident, puts out DC. It's just a byproduct of what it's doing. And a light bulb isn't bothered by DC, but a motor will die with DC. An AC motor does not want to see DC. So, anyhow, so it's basically the solid state speed control is doing more or less the same thing the capacitor is doing, but it gives you an infinite range of speeds and less cleanly, hence the buzz. And that's my best halfway layman's explanation that I can do. It's not 100% perfect, but hopefully you guys know what I'm talking about. So, starting here, we're on the lowest possible setting. I'm going to inch it up. Up to 0.1. .14, 0.15, 0.8, 0.19. I thought I saw it move. 0.2 is the magic number. Now, theoretically, the best way to control speeds on any motor would be a variac. A variac is literally a variable voltage power supply, and it's clean. And what you're doing is you can literally set what voltage it puts out. But variacs are insanely expensive, so they're not necessarily practical for, you know, somebody having one in their wall or something like that. Okay, let's go up by eighth of a turn, takes us to 0.28. Not a big difference in speed there. Another eighth takes us to 0.37. Another eighth takes us to 0.51. It's pretty quiet with the solid state control. And then another eighth will take us all the way to high. Okay. That was me disconnecting the control. It does seem a little slow to me, so I am going to check the capacitor in there. Just make sure that it's not drifted. If it turns out it is drifted, then when I replace it, which won't be till another day because I don't have any spare capacitors with me. But if I do replace it, I will do another video. Well, hope you enjoyed the video. I hope that my control information helped somebody, and I hope that you guys can help me on the safer information, especially you, Tice. So, looking forward to the comments.